Right, it's 9 o'clock. Let's do a quick sound check. Can people hear me all right down there at the back? Yes, excellent, good. Well, I know people who didn't expect to have to walk up so many stairs have still got so many stairs to walk up before they get in here, so it's fine. We'll just let people keep coming in and I'll get started. So, hi, good morning, everybody. Welcome, well done for making it in here at 9 a.m. on a rainy London morning. It is kind of impressive that after 2 days of people just talking at you, you've still been motivated enough to come here, so I feel honoured by that. Yeah, my name is Steve. I work at Microsoft. I'm on the .NET team. And I've done a lot of web stuff, and recently I started to focus quite a bit on AI. So I'm very interested in what you are all thinking and doing around AI. Hands up if you have something that you would consider AI in production in your work today. Oh, that's so much more than when I asked a similar question like 6 months ago. All right, so that's like over a quarter of the room, maybe even a third. All right, how many of you think that there's a good chance that you will in the next year or so? That's probably now about half. Okay, so I would say that that's pretty cool. You know, clearly we're moving forwards and people are starting to see the benefits of what they can achieve here. So this talk, what we're going to do is we're going to talk about AI from the point of view of application developers. So obviously there's different ways you could talk about AI. We could talk about it like as a coding assistant or something like that, and that's, you know, it's really valuable. That's not what we're going to talk about today. We're going to talk about what you can ship in your applications to make it better. But also, we're going to think a bit about how it works on the inside and how we got to here. Because, you know, we've all heard so much stuff in the news all the time about AI is doing this and that. But how did we even get to this point? You know, is this a really meaningful moment in computing history? Or, you know, is this just the way things have always been? We'll have a look for the first 15 minutes or so about the different phases of AI that have existed and how people have thought about things as time have gone on and how we got up to where we are just now. So actually, let's just get right into that straight away. So if we want to understand how we got to this point, probably one of the best places to start is back at the beginning of computing around the 1950s, when we had this guy, Alan Turing, who I'm sure you've heard of. And he wrote this paper in 1950 where he was trying to make sense of the question of, can machines think? And to answer that, you've got to answer questions like, well, what is a machine? What does it mean to think? And he was trying to work through all of these things, and he came up with this thing which he called the imitation game at the time, but now we know it as the Turing test, and you will have heard of this, that one way that we could define if a computer was intelligent was if it could persuade a human being that it was, in fact, another human being. Because then, you know, that means it's as good as a human being from the point of view of thinking and reasoning and making creative or funny statements or whatever. If it's able to do that just as well as a human, then, you know, in Turing's opinion, that would mean perhaps we should just call it intelligent. Now, at the time that he came out with this, he wasn't really in a position to test it. People didn't really have access to computers that they could program and try out. But it didn't take very long until they did. In fact, we only have to go forwards to the 1960s until they were able to try this out. Now, that's not a real picture, obviously, unless people had a much more widely varying number of limbs back in the 1960s, but I don't think they did. This just brings us to the point of one of the very first things that people did when they got access to computers in the 60s was to be able to create chatbots. So you think chatbots a new concept? It's very much not. It's like the first thing that people did. And one of them that became the most well-known and has kind of gone down in history is this chatbot called Eliza. And this was an experiment to see, okay, are people going to be fooled by this or not? The people who created it thought people will obviously see through this, but it kind of backfired because people did not, and people really did believe that this thing was intelligent. So let's have a look at it. I've got the source code for it right here, so we can see how it works, and we can run it, and we can see if we would have been persuaded ourselves, all right? So here I've got this file, eliza.mad. MAD stands for Michigan Algorithm Decoder. So it was just this early programming language here. And before we look at the code, let's just actually run it. So I'm going to need to start up an emulator for this ancient IBM mainframe called a 7094. And once I've got that started up, I can log into it. All right, so I'm going to log in as my user Eliza. and enter my password. And then I'm going to run a program called Eliza, okay? And it says, which script do you wish to play? Which is a weird question, but I happen to know that the correct answer is 100. So when I do that, it says, how do you do? I am the doctor. Please sit down at the typewriter, which is a curious term, and tell me your problem. All right, so what's my problem? I need to give a presentation on AI. Okay, and it says, you say you need to give a presentation on AI. Yes, it's happening now. You seem quite positive. Yes. Are you AI? You are sure. Are you, let's say, chatbot? Let's find out. Why are you interested in whether I am a chatbot or not? Well, it's the point of this demo. I'm not sure. You are in a demo. What makes you think I am a demo? Okay, all right. So it's just going to keep on going with this. And it seems, curiously, quite realistic. Like, I say you're in a demo, and it asks me, why do you think I am in a demo? Did they program in the concept of demos into this? Well, let's have a look. All right, so here's the source code for it. And it's a bit hard to read, but you can see here that the first thing it does, it says, which script do you wish to play? It loads this script file, and it plays it, all right? Now, what is a script file? This is script 100, which we were using just then. And you can see it starts by outputting this statement about sitting at the typewriter. And then everything after that is just a series of string replacements. That's literally all it is. So it takes whatever string you enter, it does a bunch of replacements on it, and then returns it back to you. So if I enter a string that starts with if, and then some other thing, it'll return one of these things with whatever I wrote at the end of it. So if I write if chipmunks, right, then it'll say, do you think it's likely that chipmunks, all right? So you can see it happens to have picked that particular thing. And then if you're wondering, how did it transform you are in a demo to I am in a demo? Well, it's got transformations that are set up to do things like am becomes are becomes am, yours becomes my, me becomes you, your becomes I'm. So you can see it's just flipping everything round grammatically so that when it spits it out back to me, it seems as if it's playing the other side of the conversation. Okay, so it was quite a fun little trick that they were able to do with just a bunch of string replacements. And in fact, this whole script here is only 230 lines of replacements, and yet people kind of got drawn into it. So, is this the sort of thing that we could use to build a worthwhile modern AI system out of? Obviously not, because all it can do is a bunch of predefined string replacements. If we wanted to build something that can respond to arbitrary inputs that have got nothing to do with anything that's been said before and produce outputs that have got nothing to do with anything that we've seen before, we're going to need to go in at this at a slightly lower level. We're going to need to be able to generate language more arbitrarily. And in fact, people had already been thinking about how to do that long before Eliza even came onto the scene. And if we want to see one of the first ways that people started thinking about that, we have to go back to this guy. Anyone know this guy? Probably not. Handsome chap, right? This is Andrei Markov, a Russian mathematician. And he took this book by Pushkin, and he did some statistics on it. So he was working out like what proportion of the vowels are followed by more vowels, what proportion of the vowels are followed by consonants and things like that. And he was working out the statistics of it. And then using that, he was able to create a statistical model of how the language was structured and how going from whichever letter you are at the moment, you might get to a different letter based on probabilities. But he didn't actually use that to generate any novel text. He was just using it to investigate the stats around the Russian text that he could find at the time. Now, the first person who did use this approach to generate text, at least as far as I can tell, was this guy, Claude Shannon. And he is a bit of a legend in information theory. He defined a lot of the mathematics of how we know how much signal we can get through a channel and things like that. Still very relevant today. And he took Markov's work and he showed that we can flip the probabilities around and use it as a way of generating text, which is kind of an obvious idea in retrospect. I'm not sure if anyone did it before Shannon, but he got it into one of his most famous papers. And he gave an example like this. So let's say that we want to generate text one character at a time. So what we might do is take some source text and work out the statistics of it. So we'll say, for all the A's in this text, what proportion of them are followed by another A? what proportion of them are followed by by a B, and so on. And we work out this big matrix of all the combinations. And then we can generate some text. So let's say arbitrarily we decide to start at C, just randomly, okay? And then we output a C. Then we can pick the next letter according to the statistics. So there's a higher proportion chance it's going to be an A than a B following a C. So maybe that's the one we happen to pick. So now we output an A, and then we move our state machine over to A. Then we can pick the next letter according to the probabilities there. Maybe we happen to pick a B at that point, so we output that, and then we move to B, and we use the probabilities there to pick the next letter, and so on. And we can keep going for as long as we like, and whatever text we output will follow the same statistical properties as whatever source language we used to define these numbers in the first place. And we're not limited to doing it one character at a time. We could do it with multiple characters at a time. We could do it with whole words if we want to. And we can start to produce something that feels a bit like language being generated. So to give an example of that, if we wanted to implement this ourselves, it's so easy. So here's a C# implementation of this. Now, I work on the .NET team at Microsoft, so I'm going to use .NET in a lot of these demos, but this is not specific about .NET, okay? So there's nothing that I'm going to show you today that's uniquely achievable in .NET. It's all possible across other technologies, and I'll show a bit of JavaScript as well, but I know a lot of people here are .NET developers, so we'll go with that. All right, so here we've got a Markov-style generator, okay? And literally all the code involved are these 20 lines that you can see. There's nothing else. And we need some source text to determine the probabilities that we're going to use. And so to make it relevant, how about we use the text of all the session descriptions at this conference? So I've got these thousands and thousands of lines of text which describes all the different sessions at NDC conferences. I'm sure the NDC people don't mind me scraping their website to produce this demo. And so we can use that to generate our own novel, never-before-seen NDC conference talks, okay? So if I just run this, it's going to start with the words how to, and then it's going to pick 100 words following the statistics of these NDC conference talks. So let's run that. What do we get? All right. How to use AI to consider when planning a future migration, all right? Using just shell commands, can we identify which one is appropriate for applications? And all right, well, it sort of almost makes sense. And if we run it another time, how to treat errors. What was that? How to treat errors as a part of this workshop. Okay, fine. So it sort of makes sense. It feels a bit like language is coming out of there. Now, you're not going to get tricked into thinking that this is deeply intelligent, because it's very obvious that this thing can't produce any sort of deep output. At most, all it knows is the most recent word it's output, because that's all it's doing. It's taking the most recent word that it's output and then using that to generate the next word, and then using that to generate the next word, and so on. It can't remember any more than one word back than it's just emitted. So it's like saying it's got a context length, in modern terminology, of one word. Right, so can we scale this up to build a modern AI system? And the answer is no, or at least not unless we can harness the power of 1 billion universes or something, because this will not scale, right? That was a one-character context length, and we needed 676 parameters. So for each of the 26 characters in, we've got another 26 out, and that means that we need that many parameters to store this model with a one-character context length. If we wanted to increase that to 100 characters, we would need 26 to the power 101 parameters, which is an absurdly big number. That's so big that it makes the number of atoms in the universe just look like a small rounding error. There's only 10 to the 80 atoms in the universe, so this number is just on another level altogether. This is obviously not going to scale. So we need some way, some more efficient model for representing language. And many different approaches were tried over the years. We had various neural network-based approaches. We had recurrent networks. We had long short-term networks. And the architecture that has really come along to change the world is this thing, which you'll have heard of, the transformer network. All right, so this is a particular architecture of neural networks that allows us to represent language in a fairly space-efficient way, and train it in a fairly efficient way, and this is the thing that is powering all the large language models that we see today. Now, we're not going to get into how that works internally, because that's a whole separate topic, but when we're talking about the scale of these things, let's just think about the number of parameters involved. Okay, so when GPT-1 first came out, 2018, it was 100 million parameters, and a year later, we were about 10 times bigger than that with GPT-2. Another year later, we went up by a factor of 100 from there to try and get some more performance out of this thing. And then as the years went on, we had bigger and bigger models. Well, we also had some slightly smaller open weight models, but things just generally trending to get bigger and bigger over time. Okay, so what this made me wonder is, how can we really get a sense of the scale of this thing? So when we talk about a billion parameter model, how much computation is involved in producing this thing? Like, is it even remotely possible that any of us, like mere mortals, could ever produce something like this ourselves? So I thought, let's give it a go. Let's see if right now we can train our very own GPT-2 model completely from scratch. All right, and we'll see how long it takes until it starts producing something like intelligible output. Right, so over here, I've got an implementation of a GPT-2 architecture. Didn't write it myself. It's in this project called LLM.c that you can find. Okay, and so this is a C-based implementation of something that's encoding text into tokens. It's got these layer normalization steps, matrix multiplication. What else have we got? Got some attention mechanism. Now, I'm not expecting anyone to really instantly understand any of this. I'm just giving you a sense that, yeah, we've got about 1,000 lines of C code, most of which is just mathematical operations, and that both defines and is able to train a GPT-2 model. Okay, so we need some source data to train it on. Just like before, I'm going to train it on the text of all the NDC talks. So we'll end up with something that's literally never seen the English language before and knows absolutely nothing about the universe apart from NDC talks. That's its whole world. And so we'll be able to see what kind of worldview is developed from a system like that. All right, so let's try training that right now. And I'm just going to train it for a single batch. So it's just going to loop through all of those NDC talks a single time, and it's going to use it to train this GPT-2 architecture, and we'll see what output we get. And this is the output we're getting, and it's just total garbage after one iteration. All right, now if you're wondering why does it seem to contain real words, well, it's because it's working one token at a time, not one letter at a time. So idle is probably one token, false will be a token, letters will be a token, and so on. And it's just emitting essentially random tokens after one training loop. But what happens if we train it a bit longer? So I'm going to train it over 500 loops now. And this is just running on this laptop. I'm not connected to some like server farm or whatever. It's just on this laptop. And you can see this loss parameter, second column in from the left, which started at about 11. It's going down. It's down to about 6, 5 by now. And the closer that gets to the 0, that means the closer we are that when this thing runs an evaluation, it's producing ideal results. And ideal results would be correctly predicting every single token of the output, as it should do. Okay? So it's getting lower, and as it goes on, it's getting slightly more intelligible. Okay, so far, it's more or less still looks like garbage, but maybe it's beginning to learn some grammar. So we're getting now this TWUCA event, standalone, learn the mitigating, and implementing. So we're starting to see some hints of English language grammar in there, and it's starting to use the sort of words that you would see in session talks. So it's talking about mitigating, implementing, events, learn. These are the sort of things that you see in session talk descriptions. All right, now I'm struggling a bit to show you the text because my GPU is sort of getting hammered so hard right now that I can't even scroll this window. But when it starts waking up again, I will be able to show you, okay, it's sort of coming back. All right, so we've done, I think it might have finished the training now. So let's see. Yeah, all right, so we've completed 500 iterations now. And initially, we might look at it and still think, well, that still looks like garbage. What is this? Could Facebook follow frustrating system risk, but persisted they bookend? Okay, so it mostly still looks like rubbish, but it's actually a bit better than it seems because this is sampling at quite a high temperature. And if I was to sample it at a lower temperature, then we would start to see a more intelligible output from it. So if I want to sample this in a different way, I'm going to load this into a standard language model runner. So I'm going to have to convert this thing that we've just generated, this model 00500.bin file, okay, which is in a sort of artificial format for this system. And I've converted it now into Hugging Face format, so I can then do some inference on it. So I'm going to run generate, and we can give it whatever starting point text we want. So let's say in this AI session, we will, and then we'll let it generate some tokens based on that. So as you know, as we've said already, all it's doing is it's producing the next token one at a time. So it's guessing statistically that based on, in this AI session, we will, what's the next token after that going to be, and so on. So in this AI session, we will some industry security problems, and increasingly participants will transition how to implement. All right, so I recognize that you probably won't want to submit that as a, for consideration for NDC 2026, but it definitely seems to have some grasp of English language grammar, which it didn't before we started. And that's kind of amazing in 2 minutes of training on one laptop. Because, if someone asked me to learn Japanese and said, you've got 2 minutes, go, like, I would not be able to produce sentences that had any sort of grammatical validity whatsoever. And yet this has done that in under 2 minutes. Okay, so hopefully that gives us a bit of intuition that if instead of one laptop we had like an aircraft hangar full of GPUs and we left it going for 2 months, it would probably start to produce some pretty good text. Now, maybe you don't even need that much hardware, like as DeepSeek has suggested, we can just do it with 2 laptops instead. So, we're moving forwards. We're starting to get to something that is actually producing something a bit like novel language. Okay, but this is still not really AI in a useful way, because all this is doing right now is just predicting the next token one at a time. And we don't want AI to just predict tokens. We want it to do useful stuff like answer our questions, for example. How can we make it answer our questions? Well, it won't do that by default. Let's consider a couple of different ways of thinking about what we might ask AI to do. All right? Imagine there's 2 different AI products that we want to compare, right? So we've got the token predictor, which is what we've just made there. All right, and we feed some input to it. How do I get to Greenwich Tube Station? What's it going to do? Is it going to answer the question? No, it's just going to continue the text. In this range, she said, before slamming. It's just going to produce any kind of text that seems like it could follow on from what you just entered. And that's not what we really want. What we really want is something that's like, you ask it a question, and it says, well, I'm so glad you asked. What an interesting question. Let me provide a chirpy answer for you. So that's what we want it to do. How can we take something that just predicts tokens and persuade it to answer our questions? Well, glad you asked, because I've got a demo prepared just on that subject. So what we're going to do is I'll show you how we can trick a token predictor into doing whatever stuff we want it to do, such as answering questions. All right, so what I'm going to do is let's just generate some tokens. All right, so this Azure AI Foundry, this is like a web-based interface to Azure AI services. And one of the things I can do is run some token prediction. All right, so that's a completion. It's not answering questions, it's just predicting tokens. So I say something like once upon a, and then get it to predict some text based on that. What do we think the next token is going to be? Kind of obvious, yeah? So if I generate, it's going to produce once upon a time, and then it just goes off with some other stuff, all right? So that's just going to predict 1 token at a time to continue the text that I entered. All right, and in general, this sort of thing is very good at following patterns. So if I establish some pattern like this, A aardvark, B badger, C cat, and so on, then just like a 3-year-old child, it will carry on following this pattern, D dog, E elephant, F fox, and so on. Because that's, what the whole thing has been trained to do. It's been trained to predict what a token would be in some text. And so we can use this to make it answer our questions, just by establishing a pattern. All right, so let's give a pattern for it to follow. Right. So I've got some text that says this is a transcript of a conversation between a human and a super intelligent AI. And then I've made up this syntax of my own. This is not standard, I've just made this up, all right? So we have user in brackets with a question, and then AI in brackets with an answer. User, question, AI, answer. User, question, AI, answer. User, question, AI, and then nothing. All right, it just stops. And I'm expecting it to predict some tokens based on that. So what's it going to do? It's going to predict whatever it would expect to see based on this pattern, which is going to be an answer to the question. So it predicts it is petroleum, which is a reasonable answer to this question. But then it just goes on to make up its own questions. What's the largest mammal? The whale. What's the highest mountain? Everest, and so on. All right? Which we don't want it to do. So what I'm going to do is say, all right, as soon as you've finished your answer and you get that closing AI tag, I want you to just shut up, all right, because you're finished at that point. So I'm going to add this /AI to my list of stop tokens here, which will cause it to stop generating when it produces that. So now when I generate, it produces petroleum products and it just stops. And if I regenerate a few times, then I get an error. Let's do that again. generate, okay, regenerate. All right, so each time I do that, it's just going to produce another answer to the question and then stop. All right, so that's how we can trick it into actually producing answers to questions. But what if I give it a question like this? What is the weather in London? All right, what's it going to say to that? Given that it's just predicting a continuation and it does not know what the weather is, it says rainy and cold. Yes, all right. Now, coincidentally, that might be correct today, but you know, it isn't always. And if we generate rainy and cold, so, oh, it is raining and cold, it is cloud. All right, so it's got a certain opinion about London, which is fair enough. All right, but I don't want it to just make up based on, you know, its training data. I want it to actually know what the weather in London really is. So how can I get it to do that? Well, we have this technique called function calling where we can get the AI to tell us that it needs information that we can supply to it. And a way that we can do that might look a little bit like this. So I'm going to give it another example down here. All right, so now I've modified it to say, if the AI needs to look at weather information, it emits this syntax with weather in brackets. And then we've given it an example. What's the weather in Sweden? And it emits weather in brackets, Sweden. And then it sees, and then it has answer, a tornado, and then it produces AI, there's a tornado in Sweden. So now let's say that we want to do that about what's the weather in London. What's it going to do? It's going to produce this weather answer AI pattern, hopefully. So we generate, it produces weather London, answer sunny this time, it is sunny in London. Okay, cool. But I don't want it to make up its own answer. So what I'm going to do is say, when you're looking for an answer, just stop, because I'm going to fill that bit in. So I'll add that to my list of stop tokens. Okay, so now I ask it to generate some text, and it generates weather London, like that. Okay, that's good. So I'm going to put in answer. At this point, you can imagine that this is my procedural code taking over. It sees this syntax and says, all right, we want the weather for London. We'll do a weather lookup. We'll produce an answer, zombies, and we'll see. We'll put that into the chat conversation, and then we'll generate a continuation based on that, and it produces, there are zombies in London. All right, cool. So that's how we can make it not only answer our questions, but interact with the external world. And that really brings us up to where we are today with using AI in our applications. And there are so many different applications of this. The most obvious ones, really, which I'm sure that would be the first thing that anyone would think of, would be creating chat-based systems, some sort of assistant, maybe using a pattern called RAG, Retrieval Augmented Generation, where we retrieve information and use that to generate output, in a similar way to how I just retrieved the weather for London. So, how does that look for people building code with modern APIs? Well, it doesn't look like this, okay? So this is the way things would have looked in about 2021 or something like that. Nowadays, we have much nicer APIs. I'll give you an example of how things might look today. So I'm going to switch over onto this project over here. This is actually a project template for ASP.NET Core, which we haven't shipped yet, and this is the first time that we've shown it, so you get to see a thing that we're hopefully going to release in a couple of months. And so many people, when we talk to them about AI, say, what I want to do in my business is have some way of ingesting data from the real world, some unstructured data, and then creating some sort of interface by which we can talk about that data. So that's what this template does. You can just put some data into it, so you can pull it in from different sources, like through an interface, whatever source you want, or for just getting started, you can just dump a bunch of files in this data directory, and that'll become available for it to talk about. So, for example, let's have a look at what these files are. So let's have a look at product 10, just randomly. TechBeam 2000. What even is TechBeam 2000? I don't know. It's a lighting solution. All right. Let's say we ask, what is TechBeam 2000? Then it should hopefully go and look in the documentation, and it'll say it's a high-tech lighting solution, and it provides a citation. It finds out that we were looking at document 10.pdf. We can ask it other questions. What features does it have? Okay, make me a table of features. And we can get it to produce some, nicely formatted output with tables and stuff like that. All right, that's fine. But what does that look like in terms of code? Well, we've got, in this case, it's a Blazor UI, and we've got a system prompt. And so this is the sort of API shape that people are going to be using today, where we have a conversation that's described as a list of chat messages. And so that really is a way of representing something a bit like this thing that we had before, except in a more object-oriented way. And we can attach functions to that. in the same way that I did the weather thing just a minute ago. So where's all that done? It's here. All right, so here we're defining the functions that we've got, in this case, just a search function. So it's able to look up stuff from the documents available. All right, now to get more of a sense of that, let's say we want to add support for doing what we just did a minute ago. What's the weather in London? Well, it doesn't know, right? Because we haven't given it the ability, and we've told it in the system prompt, don't answer questions that you don't know the answer to. So it's just going to say, I don't know. So let's give it the ability to do weather lookups and see what a more up-to-date API for that would look like. The way it could look would be something a bit like this. So let's say we have a method called getTemperature that takes a latitude and longitude, and it's going to return a temperature using this open web service that we've found over here. Now, we don't want the user to have to type in latitude and longitude. We want them just to give, say, a city name or something like that. So we'll also add a function called getLatitudeLongitude that takes in a location and does another web service call to find the location. And so if the system is smart enough, it will combine these two to be able to answer the question. So let's just put some breakpoints and see if it actually does. And also, before we run it, I'm going to have to actually expose those functions to it. So here, oh, look at that, Copilot's already doing it. So we're going to expose those two functions. It gets the indentation wrong, though. Why is that so hard? But it figures out everything else that I want. And then we'll run that. And now, hopefully, we'll see that when I ask that question, it's able to call my functions in the right order in order to resolve that question. So when that shows up, here it is. Right. What's the temperature? And it says, give me a name of a location or its latitude and longitude. So you see, it knows the metadata about what functions are available, and it's telling the user what it can work with. And I'm just going to say London. Oops. Oh, I didn't press enter. Press enter now. There we go. And you see it's called getLatitudeLongitude, and it's passed in London as the location. So it'll get those coordinates, and then it calls getTemperature, and it passes in the latitude and longitude that it just received to get back a temperature, and then it's going to output 8.3 degrees. All right, so it works, and that's the sort of API pattern that you'd expect to see today. Now, of course, we're not limited to just building stuff that looks like a chat interface. And I think that sometimes we over-focus on that a little bit. And I would strongly encourage you, if you're thinking about, like, how can I use AI to add some value to my products, maybe don't even think about the UI initially. Think about stuff that you can do on the back end without any UI associated with it, because there's loads of stuff that you can do. For example, let's say that there is unstructured data out there in the world. You want to extract stuff from that and use it to update your systems. Maybe you want to automatically classify things to automate some kind of workflow that you've got going on. Maybe you want to summarize some text to make things easier for users, detect if people are posting toxic content, or score how happy or sad your customers seem to be, or just simply to translate between human languages. Well, it's really easy to do that sort of thing. Let's look at a few examples of that. I'm going to switch over on here now. All right, so I'm going to use this library, Microsoft Extensions AI. If you're a .NET developer, you'll be interested to know these are our new standard abstractions that represent AI services. So language models, embeddings, text-to-speech, things like that. So standard in .NET. We've got a preview out right now. It'll be shipping as stable fairly soon. Okay, so I'm going to use that right now. So what I need to do in this case is use an iChat client, which is the abstraction over language models. There's implementations for Azure OpenAI, Mistral, Gemini, DeepSeek, whatever you like. You can get an implementation of iChat client, and then I'm choosing the model I want to use. All right, now the scenario that we're going to work through here is extracting data from these property listings. All right, so we've got a long list of just arbitrary text that's been written by some estate agents or whatever, describing some properties that are available. And let's say the first thing we want to do is just work out which ones of them are sales and which ones are for rentals. Well, we can do that really easily. We can just loop over them, and then we'll get our chat client and say for each one, is it a sale or a rental? We just literally ask it, and it's going to give us back an answer to that. So if I run that now, it's going to do nothing for some reason. Why did it do nothing? I don't know. Let's do that again. What's going wrong here? Build. Rebuild that. I have no idea what's going on there. Oh, I'm running the wrong project. That's all right. Thank you, everyone. All right, great. let's do that again. Okay, so it's now going to loop over all those things, and it's going to say, all right, this is a sale, this is a rental, this is a rental, this is a sale, and so on, all right? So in a sense, we're doing classification right now, but it's not very useful because I don't just want back a big string that says in English what this is. I want back some structured data. So as a programmer, I'll be thinking about this in terms of like, I want a record called property details, which has got a listing type of sale or rental, and then just to show we can, we'll extract a bunch of other information from there as well. All right, so let's try doing that now. So this time, what I'm going to do is when I call complete async, I'm going to pass in the type I want as a generic parameter. So I'm saying, extract info from this text and give me back a property details. All right, and that will constrain it to reply in that particular shape. And then just to check that it's working, we will emit a JSON serialized representation of that to the console, just so we can see what we parsed from there. All right, so we run that. And what do we get? Well, we get these nice JSON objects that do, in fact, extract information from all that arbitrary human-written text, and that's excellent. So that shows various examples of this stuff already. So that shows us how we could do classification to identify whether something's sale or rental. We've got some summarization in there when it produces this 10-word summary. We've got well, we don't have sentiment scoring, but it would be fairly easy to add that. In terms of translation, this is incredibly easy for us to do as well. For example, we could just go here and say, as well as the 10-word summary, I want a 10-word summary in French. And so if I run that again now, then as well as producing the English summary, then it's going to produce a French summary as well. So let's see what have we got. We've got an elegant 4-bedroom home, or a maison élégante de 4 chambres. So it seems to, be able to do some translation very straightforwardly. Okay, so that's a bunch of simple examples. But so far, we've been relying on using some pretty big machinery to make this work. So you'll notice up here, up at the top here, we're using GPT-4o Mini, which is, despite having the word mini in its name, is still a very large model. Okay? And if you were dependent on this sort of thing as being a really core, low-level part of your product, you might think, can we make it smaller? Can we make this something that's quicker and cheaper to run, that runs on our servers just directly? And so that brings us onto this subject of small language models, as well as large language models. And for many scenarios, you actually can use a much smaller model than something like this, and small enough that you can just run it on your server. In fact, although you probably shouldn't, you could even run it directly in your end user's browser if you want to. So I'm going to show you an example of doing that. Not that I think you should, but just to make the point that these things are small enough that if you can do that, you should believe that you could run it on your server as well. So let's do a little bit of classification just using a small model. And I'm going to do this with a bit of JavaScript. So here I've got an HTML page, right? And we're going to put a classification system into there. So let me just get that up in my browser. So there we go, right? What I'm going to do is use a library called Transformers that's produced by Hugging Face, which is an online community. Transformers is a library that can run a whole bunch of different AI workflows on JavaScript. And in this case, I'm telling it I want it to use this model called Deberta v3 x small. And I want it to be, that's a general language model, by the way. It's quite a small one. And in this case, I want it to be set up for zero-shot classification. And what that means is we take some input text and it gets classified as one or more of a set of labels. And the zero-shot bit means we're not doing any special training for our scenario. We're just, on the basis of no other information, giving it some text and labels and telling it to give us the relevant labels. Right, so I've wrapped that up in a function called getClassifications, which takes our input text, and it's going to return one of these 3 labels. In fact, not just one. I've told it can return as many labels as it likes based on whatever it thinks is applicable. Okay, so let's go over here, and I'm going to load this into the browser. And it's a bit big of a model to run in the browser, and it's producing a bunch of these kind of warnings about performance. And if we go over here and look on the application tab, we can see how big is this model that we've got here. So this is the thing it's just downloaded, model.onyx, 284 megabytes. It's a bit much to put in a web page, but it's totally fine to be running something like this on your server. All right, but let's just try doing it now. So let's say I want to do this asynchronously. Get classifications, I want to buy stuff. How is it going to classify that text? Well, it comes back saying, all right, for these 3 labels, sales, complaint, and servicing, it thinks that sales is a 77% match, complaint 27%, servicing 18%. All right? Now, they don't have to add to 100 because it can use multiple labels, but clearly it thinks it's mostly about sales, which makes sense. All right? Now, to get a sense of the performance of it, let's try doing this on every single keystroke as we type into that text area. So I'm going to make a JavaScript event handler here that's going to listen for keystrokes or inputs on this text area, and whenever they happen, we're going to run this classifier. To do that, I'm going to do this, where firstly, I want to make sure that we've only got one task running at a time. Because if I run multiple classifications in parallel, because the user types while I'm still classifying, then it's going to be bad for performance, and also it just doesn't work. So I'm not going to do that. I'm going to only run one task at a time. And then once I'm sure that I am the current task, I'm going to get classifications for the input, and then I want to display that in the UI, which I'm doing in the most basic possible way. I'm just erasing the previous output, and then I'm going to generate a set of list items that contain the classifications we've just generated. So let's try it out. Let's say I need to book an MOT. All right, so for people who are not British, MOT is a test that you have to do for your cars, so it makes sense that servicing would be the thing that it picks out for that. But if I keep typing for my horrible car, then you'll see, as well as servicing, it now detects that there's a fair chance that this is also a complaint. All right, so that's an example of how we can bring in a small language model to do some of these simpler tasks like classification. Now, there's many other things that we can do with these sorts of systems as well. For example, vision. You know, we're not limited to just working with text. We can work with other types of media too, whether it's images, audio, video, stuff like that. Let's just run through a quick example of that. So switch on to this vision project. So over here, I've got a bunch of code that you can largely ignore. This is just getting an instance of an iChat client from a dependency injection container, just to do things in a slightly more realistic way, but it doesn't matter. And what I've got this time is a bunch of images from traffic cameras. Right, so here's an image. And what we want to do is extract some information about what the traffic conditions are and whether there's anything dangerous going on. So you could imagine that this is an approach you could use in any sort of industrial environment where you want to detect, like, in this factory, is everything okay right now? Is this product that's just come off the line, does it look right? Is there anything obviously wrong going on? That's the sort of application there. And in this case, I want to get back a traffic cam result that looks like this sort of structure. So I'm looping across all the images there. And what do I want to do in each case? Well, I want to do something like this. I'm going to say, let's construct a chat message that says, extract information from this image. We'll attach that image content, the actual binary data of it, to that message. We'll send that in, and we'll say, give me back a traffic cam result, and then we'll display the output from there. Let's try that. And it's going to loop through my images, and it's going to say, in the first case, the traffic appears to be fine. The next case, it's also clear. It's also looking fine. And in the last case, it says it's blocked. Okay, let's check if that's actually right. So for 3242, is it really correct that the traffic is blocked? And the answer is yes. Clearly, there's something pretty bad going on the roads there. And that might make us think, all right, perhaps we want to get some kind of alerts if there's really bad stuff going on the roads. And we can use the same technique that you've already seen. So you've seen how we can condition the system to call our functions if certain conditions are met. So what I'm going to do now is I'm going to add a function called raiseAlert, which I'm just defining as this lambda that takes the camera and the alert reason. And we could do other things, but for now I'm just going to log stuff to the console to say we've had an alert. All right, and then I'm going to make that available when we call complete async. Right, and I need to tell it when to raise the alerts. Like, I don't want to have an alert just because, say, there's a red car or something like that. I want to tell it to give me an alert only if the camera isn't working or if there's something dangerous happening. So run that one more time. And we'll see, hopefully, it might start to raise some of those alerts now. So in the second camera, it says that the camera is malfunctioning, which is interesting. We probably want to know if that's the case. The third one, it's fine. And the third one, it says, oh, it's dangerous. There's sheep blocking the road. OK? So that's great. That's exactly what we wanted. Let's just check that this one's right. 3199. Has the camera malfunctioned? Yes, it clearly has. So that's another thing that we would want to get notifications about. All right. So hopefully, the point is reasonably clear that we can use AI to implement a whole bunch of business process automation. It doesn't have to have a chat UI, even though that's actually quite commonly something that people want to use. So where do we go from here? Like, what's going to happen with this sort of stuff coming next? Well, one of the main patterns that people often talk about at the moment is agents or agentic systems. And this is the idea that instead of just making a single call to an AI service and saying, just give me one answer at a time, how about we give it the ability to do a whole series of tasks by itself, okay? So we'll allow it to run a loop where it can make many calls and where it can collect information and do stuff over a period of time. For example, you can imagine as a software developer, you've got some task like upgrade my application to the next version of something or other. And you could imagine being able to provide an instruction like that and having your assistant agent go and do a bunch of web searches to work out, like, what is the new version of stuff? What are the common upgrade steps? And then do some calls to look at your code base and work out which parts of it do I need to upgrade, and then provide some report to you saying, hey, this is what I think we should do. And then when you've approved it, also do a bunch of work to produce some diffs that would apply to your code, maybe do some more code calls to run your tests, all that kind of thing, right? Hopefully you can get a sense of how we can build a bigger process on top of the ability to make these language model calls. And it's an area that a lot of people are pushing towards at the moment. Right, now that's maybe a little bit further ahead, but in the more short term, I think there are some things we could do right now that we would be able to improve our software with that people aren't fully taking advantage of right now. So there was an example of this that Scott Hanselman gave in the keynote a couple of days ago with this example of a smart form. So in this form, the user can just copy some text to their clipboard, and then after they've done that, instead of having to type out every field by hand, they can click some smart paste button, and AI can match up the clipboard contents with the form. So really simple concept, very easy to implement, but really is going to save your users some time. Or we could do other examples of things like that. For example, you've all seen autocomplete systems. But what if instead of it just having a fixed set of understanding that's common to everyone in the world, like a single thing based on the English language, how about if it knew about the scenario at hand? So it knew about exactly what the user's trying to do at the moment. It knew about what policies there are in the company, what web addresses, what email addresses, things like that, and was able to provide much more intelligent completions based on all that context. Again, totally achievable with current technology, but we're just not seeing that much of it yet. So I think that's a good opportunity to consider taking. Or an even simpler example is just semantic search. So anytime that your application asks users to type in some search term, then instead of matching by string exactly, how about you match semantically? It's really cheap and easy to do that with a small embedding model. So we can, the user types in cat and it comes up with pet care, or plane and it comes up with travel. Maybe the user didn't know what the exact expense category was. So that makes the software a lot easier to use. Okay. Now, one other area that I think is really interesting at the moment that we could start to see coming into land in many of your software applications would be a bit related to these things. So, these things like these intelligent assistants that people have in their houses. I don't in mine, but many people do. And so you can go and say like, hey, Siri, get me a recipe for this. Or Google, what's my meetings for today, right? You know about these things. But what about if instead of making one that was just sort of a generic consumer product, you had an assistant that was actually part of your application and knew about exactly what your application can do and what the user is trying to achieve and was able to guide them through the process of doing that. So let's see an example of how we could do that. So I'm going to show another demo right now. Let's go over here. All right, so in this application, and I'll show you some of how it works, and we'll implement a bit of it ourselves in a minute, but let's just run it firstly. All right, so this application is for listing vehicles for sale. So I can come in and I can start typing in like Nissan, I don't know how you spell that thing. Anyway, you can start typing all that stuff out, but what if we could get the system to help us do it? So I could just turn on my microphone and say, okay, so I need to list a Nissan Qashqai from 2006. And it's done 200,000 miles, and all the tires are in good condition. Actually, no, the back tires are badly worn. Okay, so that's pretty nice as a user experience, but so far it's just basically a kind of speech recognition. Could we take this a bit further, and could we make it able to operate parts of your software, like this button here where we can add items to a list? Can it just operate that for us? Right, so let's describe the condition of this car. It's in good condition, it's very nice and clean, and it's got the right number of wheels. Okay, and it's also parked in a very prestigious parking spot. Okay, so it's able to operate these parts of our application, and that's good. But what I really like about this even more is that this is not just speech recognition. There's actually an intelligent assistant behind this. So it can do things that we haven't written any code to make it able to do. So let's say I wanted to swap the front and back tires. Well, it would take me quite a lot of clicking to do that. And I certainly haven't implemented a feature in the code for swapping tires. But I can just say something like this. Actually, swap the front and back tires over. So you see they've just swapped around, which is nice. That's saved the user some time. Or maybe I can do some editing. Right, so for these descriptions, I want you to make them sound a lot cooler, like they were written by a salesperson. Yes, that's good. But actually, no, I want it to sound way cooler still. So make it sound like that it's written by someone who's completely manic and aggressive, and put some of the words in all caps for me, OK? Yes, good. Dominates the prime point, yes. But actually, I want some emojis in there. So next to some of the words, put some relevant emojis, OK? All right, where are my emojis? Get an emoji into each one, please. Ah, there we go. Yes, excellent. And can we put them into alphabetical order? Oh, they are. Yes, excellent. Can you prefix each of them with Roman numerals? So it's like I, and so on. All right, lovely. OK, so that's clearly a much better. All right, thank you. Yeah, appreciate it. It's a much nicer user experience than just like tapping out stuff on a phone and trying to copy and paste stuff and drag stuff around. And you know, this sort of thing is achievable today. So let's look at how we can implement something like that, shall we? So I'm just going to go to my source control and move to a different branch where all of that feature is gone. Reload that project and come back over here. And when that reloads, OK, our microphones and stuff have gone. All the functionality has just been removed because we're going to implement it just now. All right, so how do we do it? Well, in this case, it's a Blazor server application. Obviously, it would work with other UI tech too. But here in the homepage, I'm going to start by adding some microphone control. So the user can turn the microphone on and off. And I've already prepared that. So we're just going to drop that in. And that's going to react when I click on it by changing the microphone status. And then it's going to activate this other component that I've got called the conversation manager. Right, so that's a little bit of C# code. It's like 60 lines of code. We'll see quite a bit of it. And that operates on an arbitrary model type, T model. And in this case, the model type we're going to pass in is car descriptor. So that's going to have make, model, year, tire status, all that sort of thing. But this conversation manager doesn't know anything about that. It can work with any model type. All right, and then what does it do? Well, it's got this prompt saying, you're helping the user to edit a JSON object. It conforms to this schema. And we can calculate the schema based on the type that's been passed in. And we say, listen to the user, collect information from them. When they provide information, I want you to add it to the JSON object. And then I've got my UI tech, Blazor, to just bind that JSON object to the UI. So whenever the AI system updates it, it's going to show up in the UI as well. All right? And then we're starting a conversation using the OpenAI real-time APIs, and we configure it. And then we don't do anything. So let's put in the rest of the code. OK, so what we're going to need to do is we're going to have a loop. Because this is a real-time system, it's going to be able to send us messages at any time, and we can send it messages at any time. So we're breaking out of the pattern of just making individual chat completion calls. So we get these messages at any time, and the first one we're going to get tells us that the conversation session has started, and we'll start sending some audio to the system. And then other messages that we might be interested in are input speech has started or input speech has finished, and we'll display a message when that happens. Right, so let's see if this works so far. All right, so I'm going to start talking. Let's have one tab. OK, so when I start talking, it says speech started. And when I stop, it switches to saying speech finished. All right, so it knows when I'm talking. And in fact, it's already starting to produce replies for us. We're just ignoring those replies right now. So what I'm going to do is say whenever we get a response or a streaming part delta update, which is a great name, we are going to enqueue it on the speaker, because it's actually going to provide audio output to us. It's also going to provide text. We'll capture all that in a string builder. And when it finishes talking to us, we'll display all this text that we've captured like a kind of subtitle. All right, so let's try that again now. So let's see if it will reply to us. Hi there, what do I need to do here?
I'm here to help you edit a JSON object for a car you want to list for sale.
Awesome, thank you. What information do you need?
To update the JSON.
Oh, right, I'm speaking too often, there's a bit of noise, but never mind. All right, so you can see it's able to produce audio output for us as well. That's great. But I don't really want to hear it talk to me. I find it kind of a bit annoying and slow. I'd rather if it just responded with some text really quickly. So what I'm going to do is I'm going to go to the options here, and I'm going to change it so that the content modality is just text. So it's just going to produce text output for me. And also, because the voice detection was a bit sketchy then, I'm going to change the parameters from when we detect that the user's speaking or not, so that it becomes a little bit more reliable. Also, I don't want it to give me just random replies. I want it to basically just do what I say and don't say anything back to me. Just do what I tell you, okay? Only give me a response in text if I actually ask for it, all right? And then finally, as well as just producing text output, I want it to update this JSON document, all right? And to do that, I've defined an AI function, just like we did before, which is going to take whatever type of model it produces from this JSON document, and then we're going to send that into the UI to update the UI. So I just need to make it call that, and the API that we do that with looks a bit like this, handle tool calls async. All right, so I know that that might not be familiar, but that's how it works. So let's see if we've got all our functionality back. Right, I need to list a BMW 5 Series from the year 1822. Okay, why has the year come up in red? Okay, so it works, and also we've got some pretty fancy validation going in here. It knows that the BMW 5 Series was introduced in the 1970s. So, you know, that's kind of nice, given that I didn't even have to write any code for that sort of thing. All right, so that's an example of how you can create an assistant that's built into your application, knows about the workflow that the user is going through, and helps them with that. If you want to get the code for that and try that out yourself, then there's a GitHub repo right there. All right, so that's going to be all we have time for this morning. So in summary, what have we done? We started off with the Eliza chat system and how it was just a bunch of string replacements. We went through a Markov modeling for language through GPT-2, and we trained a system and got a sense of how long that took. We went through a whole bunch of business process automation with structured data extraction and image models. We looked at small language models. We've ended up looking at real-time voice-based assistants. So I hope that something along the way has been at least a little bit interesting or useful to you. I hope that you have a really good last day of your conference. So yeah, that's all from me. Go and have a really good day.